but of course we'll be seeing you in the future as well for follow-up studies. We'll turn this over to you.
Thank you very much, and thank you to all of you for being here. After my talk, I shall dash fast, well, not so fast, but steadily to York, Pennsylvania, 12 hours. So if you like to contact me at any point in time after the talk, these are my coordinates, by j@si, smithsonianinstitution.edu. Okay. Next slide, please. So this talk will, as Jim said, be mostly about bees, but it will have time permitting some one slide punchline on some of the other projects. So this is the official title. Next slide. This is the real title. Let's see if the pointer works. So on May the 7th or May the 8th of this year, when was the very day or the day after I arrived here.
Kelsey,
yes. I was checking my thoughts, the dog, and there were two ladies who were at the lake on the other side of Lake Lindenwood, and they said, "Oh, you are the man behind the cups," and they pronounced a memorable phrase. We don't remember you, but we remember your cups. Okay. And I will be talking about some other things. These are, of course, the cups. Next one, please. That's the philosophy that I have every day of my life. I am grateful for waking up healthy, etc., and go, with energy. Life is a gift. Next one. Maybe. Okay. So this is like, I can have the previous one.
Yep. I'll think about it.
Maybe. Okay, so I collected everywhere. Okay, collected bees everywhere. And here is Lake Lindenwood, formerly known as Lake Ravenel. And the most important character is in the center. An alligator turtle. And I actually call this side El Sitio de la Tortuga, which means the side of the turtle, and the culebras, because there are. Yes, let's read. Thank you. So I collected everywhere by any means necessary. Someone who I believe is in the Zoom room, thank you, Kelsey, helped me fix the colorful cups with holes so that when it rains a lot, the exit, hopefully, water only, not the little bees, hopefully, exit. So here are the cups, and I intentionally photographed this photograph because it carries the name, a number that all Puerto Ricans of my age remember, number 21, patrolling the right field of the Pittsburgh Pirates, Roberto Clemente. Okay, sweep net everywhere. Thank you, Kristen, for being our skipper. Vacuum a few times, not very effective. And thanks to Jason and of the crew, we went where no bee person had gone before, or not very often, to the canopy, and that's exciting. Next one, please. So, as Jim said, the father of Eastern North American bees, Theodore Mitchell, was collected in quote-unquote islands from the 1920s to the 1950s, ballpark. So it's about 100 years. How did I get into this project? Well, last summer, I was going to take, and actually took 3 courses here. And I tell my dear friend, Mr. Sam Brody, the big guy, hey Sam, do you need some bees from Highlands? And he said, Jorge, coincidentally, 100 years ago, the father, yada, yada, yada. Why don't you get some decent work on them? So instead of being Sam's project, it became my project, and I get to know and learn more about this. This is, so after Theodore Mitchell, the next person that I am aware who worked with some intensity, specifically at the Highlands Biological Station, was Miss Leah Purvis, an undergraduate at Western Carolina University, who collected mostly in September of 2017. And that's the bulk of her collection. There are some other specimens here. In 2.5 weeks, I collected these. I don't remember how many different species she got. We got 22 species, and at that moment, Sam told me, Jorge, consider returning. And I said, yes, sir. And I considered returning, got the funds. Thank you very much to the members of the board, and to Penn State York for funding me for the classes, which I always love. And this is what we collected. Okay. I could have collected easily, maybe 1.5 times more, if I would have sat at the pollination garden and decimated all of them, which I did not do. I promise. And by the way, last year I was stoned 4 times simultaneously, boom, and boom. This year, 7 times, one at a time. Thank you, please. I'm not only interested in what these are here, in other words, from the point of view of an inventory of what are the bees of the Highlands Biological Station, but I'm very interested in what are the insect-plant interactions, or specifically the bee-plant interactions. So we can make direct observations, at the bees. This is possibly an andrina. I have to look at it carefully with a package of pollen from Asclepias, okay, just attached to the legs. They are really sticky. Now, besides that, we cannot be chasing as much as I wish. The technology is available, but it doesn't seem to work right. In other words, there are inalambric monitors that one can attach to a bumblebee, which I very much want to get a hold of. But colleagues who know more about this than I do told me that there was a big of, a lot of, brouhaha about that, but that it doesn't work. Okay, so in lieu of that, bees have the great advantage to carry some sort of evidence of their previous visitations in the form of pollen. Okay, so what do? We steal the pollen from the dead, from the dead bees. I don't think they'll be happy to be alive and we try to, okay? So what do? We ask a wonderful technician, Kelsey. Thank you, Kelsey. And to get you fixed with a bunch of liquids, stains, and you just try them all. Because one of the questions I had was, okay, is there a master list of all of the stains or dyes used by humanity to stain pollen? And the answer is no. On any plant. My questions are usually, give me the whole shebang, like God's list. And the answer is no, not surprisingly. So Kelsey was able to get me 7 or to fix 7 liquids, and for every bee that whose pollen removed, we prepare, or I in this case, 7 slides. So it becomes very colorful, beautiful. Okay, and so this is my first preparation and if we could remove this thing, not herbal. Thank you. So this is something that, or this is an image that David used. This is fallen from rhododendrons, one of my first bees. And so before coming over, just with light microscope, okay? And I said, oh my God, it works. I was very happy. I said, oh my God, yippee. So David had so very kindly put me in touch with Dr. Bob Euchre at Western Carolina University, and he is the master within Western Carolina University of all things microscopy. And I went where I have never been before with fluorescence microscopy. And all you do is just to proceed as usual up to this point, and then depending on, oh, yippee. Thank you. Thank you, thank you, thank you. You know, depending on the color of the object being examined, source of illumination, you know, the wavelength, and the chemicals added, we get not only to see this, but to see pollen that stains different colors at different points on their, you know, morphology. We don't have time to explain that today. So this is pollen of water lily that has been digitally combined to produce that image. In other words, with 3 different wavelengths, etc. It's just fantastic. And this is pollen of blackberry, shown here, kind of circular, and then some other pollen, immediately indicating to us that this bee has been in several, more than one plant. It's just a tremendous tool. I will have one more thing to say. Not only that, with this technology, we can 3D pollen. Now, the original image is a little bit flat because remember, it's on a microscope slide with a cover slip, so it's a little bit flatter. So I just extended the vertical axis to return to the pollen is more or less a spherical shape. Next one, please. Okay, let's talk bees. Okay, so the happy face, and this happy face should go here. Well, I should have been eliminated. My fault. The happy face means that that particular family is present at the Highlands Biological Station. And I will tell you, Eric, no idea. Yeah, sorry, Eric. We have these 5 families, the Apidae, the Megachilidae, the Adrenids, the Halictids, and the Collectids. We have 5 so far families here at the station. Now, the first thing that you do, that we all do, if we want to do this, is to look at its face. Does it have a long tongue or L teeth? Let's see if this is working. Yes, it is. This is their advanced state, okay? So this is a long tongue, it's part of the labium. Or does it have a little tongue? And it would be 1, 2, 3 families. Okay, so long tongue, honeybees, and their allies, you know, bumblebees, carpenter bees. Long tongue, also megachilids, which we don't have very many here. We used to, I will say a word about that in a second. Everybody else, short tongue. Next slide, please. Okay, now let's look at the bees with a long tongue. Okay, first, if a bee has a long tongue and has a wide labrum, this part here is called the labrum. It is wide. It goes in the family Apidae, honeybees and their allies. Now, these guys have given it to me with generosity. Okay, these are the 2 most common, as far as I can tell, bumblebees here, bombus impatiens, which some people claim that got that name because it gets very irritated in a hurry. Or bombus bimaculatus, which has some imagination, 2 yellow regions. Okay, we have also there the big guy, the carpenter bees, right? Okay, bombus are large and hairy, you know. Okay, Xylocopa is larger and not so hairy on the abdomen, okay? We have Apis mellifera honeybee, which is not always yellow and black. It can be almost completely black. And I said, my God, what happened to this guy? Okay, and this little guy, which is about, what would say, maybe 4 to 5 millimeters long, Ceratina. By the way, the smallest bee on the planet, I think, is something called Perdita minima, is minimally 2 millimeters long, the whole thing. Okay, the largest bee in North America has to be a Xylocopa, or some of the big bombus, which, as far as I know, we don't have here. Right? These animals can be big. In the word, I completely forgot his name. There is a bee in Indonesia which appears to be very rare, which is about this bee. Okay. It's still not as large as the so-called murder hornet, which I have seen in person there. Next slide, please. Feel free to ask questions. Now, more bees related to the honeybee and carpenter bees are these guys here, nomada. Now, you should have been asking yourself, Jorge, how can we tell a bee from a wasp? Generally speaking, wasps tend to be slender and not a lot of hairs or setae. And if they have those setae are straight, in contrast to bees, which tend to be a little bit, fatter, chubbier, I love them, hairier, and the hairs are plumose, like a feather. Of course, all under microscope. When we see nomada, I say, ooh, well, that looks like a bee who wants to be a wasp, but with some experience, this son of a gun. I know you. I know you. And it has, the nomadas that I have seen all tend to have this yellowish and black color, like a tiger. And then these species, as far as I'm aware, I have not collected Cyterus, which is supposed to live in the highlands, according to Mitchell, which we haven't found here. Next slide, please. Okay, so I have a big list, which I will not go in any detail, but you will see slides like this. On the pale green column is what Mitchell reported, the grand total in his expeditions from the 1920s to the 1950s. On September of 2017, I should add that, this is not 1917, is what Miss Leah Purvis collected. And this is my two explanations, my two visits. You will see a very common pattern, which is many of the things that Mitchell reported, and I am not about to question his identifications. I'm not ready to do that. Yes, Julian. No one else can find. So we can talk about the meaning of that later. Next slide. Okay, now let's do the bees that have a long tongue and a long labrum. Okay, and that's the family Megacylidae with 3 genera: Osmia, Coleopsis, and Megacylidae. Okay, so Osmia is a common bee here. The Osmias tend, like the Megacylidae, tend to have kind of a chubbier, they have a certain kind of morphology of the abdomen that I cannot describe. I don't know if you can see it, kind of a little bit bigger towards the middle. There is a certain gestalt to the osmias get them right away, and they tend to be metallic. Okay. Coleoxys, also present here. Yes, there. Okay, next slide. People from the library and say, okay, here is one of the big stores. Megakindly. Mitchell reported 13 species of megakindly for quote unquote highlands. How many have we found? 1. Okay. And this is the one we have found, megakindly mendica. These are not microscopic bees, these are visible bees. Okay. And this is an example of the one of the 13 that he reported and we cannot find. Next one, please. And that can be seen patently here. Okay, look at this. None of these, and on the next slide, almost none. Here is the only one. Okay, megakindly mendica. Everything else on the megakindly and Coleoxys 0 so far. Next slide, please. Okay, let's now look at the bees with a short tongue. Okay. Now, here is where the action of many species that are little and littler takes place. Okay. So first family Halictids. Okay. No, my mistake. First family Andrenids. If you look at the wing of an Andrenid bee, it doesn't have this yellowish structure called nigma. Okay. There are some other things on the wing called nigma, unfortunately. Okay. But if you don't see this yellowish cell and the bee, as you look at it face on, doesn't have a long tongue, then it has to be an Andrenid. Many species, many. And this is a fairly common one here, the Andrena imitatrix. We have, I think, about 15 to 20 species here. Next slide, please. And how many? This is, again, look at the pattern, what Mitchell reports, what Ms. Purvis has found, and what I have found. Many of the things that either Mitchell did a report or I haven't looked sufficiently, which is always a possibility, changing the season. Next slide, please. Okay. Now, here is where the beautiful things come in. Now, warning. These are typically smaller than a typical Andrenid. So we are of course, in the family Halictida, typically smaller than the already small Andrenas and very colorful. So we have here at the station at least, or at the Highlands, at least 4 genera of green metallic bees on your face like a race car. Okay, they are beautiful animals, tiny. Okay, at my other study in the Richard Nixon Park in York County, Pennsylvania, this guy here, Ovochlorella, is the most common bee, no question. Okay, now there are some other bees that are not metallic green or metallic blue, but that have stripes like that. You can in the Highlands, and you can guess on a first pass that it is probably a Halictid. And then you get into the, shall I say, diabolically small bees. It's really true. You definitely need a microscope, and lenses may not be enough. Okay, the genus Lasioglossum, and I intentionally chose this particular species found in 2008 in the city of New York, in one of the little parks we found within the city. Oh, this is a Lasioglossum. Oh my God, it's a new species in the downtown. And we have it in York, and I was so happy to see, Gotham here. It makes me think of Batman. Next one. It's a lot of fun. And here is again what Mitchell, and look, there are lots of Lactoblossum. This is the most specious genus of bee on the planet. The second one is, of course, Andrina. 2 headaches, okay? Not one. This is what he reported. He, meaning Mitchell, is what Miss Purvis collected in 2017. This is what I collected, and by October of this year, I hope to have that filling with more rows and more exits. Next one, please. Okay, finally, bees with a little tongue, and the end of the little tongue is anything except bilobe. Now we have 2 genera here, the genus Coletus. These are rather big, big bees. And then these little bees, Hyalius, which are very common here. Very, very, very common. They are about this size, maybe 5 millimeters long. How do you recognize them? Entirely black or very dark brown with these little yellow markings all over it. Oh, what a beautiful bee, right? Next one, very easy to recognize. And again, here is the chart. What Mitchell, reported 0. Well, we have only found, I found Colitis thoracicus earlier in the summer, and then look at all of these species of Hyalius and how few. So things are happening. Next one. Any questions? So, any questions? That's the rundown of the pretty pictures of the pretty bees. Now, punchline. So far, I'm counting. Emphasis in and counting. Because we have about 300 to 400 bees unidentified yet. Okay? A lot of work. Inside quotes, whatever Mitchell calls the Highlands. It's not completely clear to me exactly where he went. He once stayed at the Highlands Hotel. So he must have been in this area, but he went elsewhere. Okay, the key function line, 12 species of Megaphylis, nowhere to be found. And I have completely forgotten to give credit to where most of these images come from, either from Discover Live or from Flickr. New records. About 2/3 of the things that we are finding are things that Mitchell does not report. And things that Mitchell reported that we have not found, 31 out of 44, I should have put here the percentage, about 75%. If we count all of Mitchell's report for quote-unquote Highlands, and the grand total is 88, I want to be more conservative and see what comes out. Okay, one possibility is effect for all of these changes is effect of deforestation around here. Remember, Mitchell began collecting in the 20s, and the Highlands were gained for big time deforestation. Now, this is more easily testable, the effect of the season. Miss Purvis collected in September. Mitchell did some collecting in September. If I can return in September of this year, I will, or maybe a couple of weeks max when there is a big bloom, and see if I get anything else. Next slide, please. Okay, what I have learned, and all of these are from me. Not the best yet. I'm not that good of a photographer. Okay, where do bees like to go? Well-illuminated areas like the pollination garden or the vegetation near a wooden plant. Whenever there is a big clear, Even if it is in the middle of the forest, you can sit there. There are plants in flower. Get your sweep net ready. On we go. Next one, please. This is in the forest trail, and there is a gap there. Many of you probably recognize this. And there were bees on them in one of my cups. And if you just look up, ooh, there is a clear. So bees seem to like that. Next. Huge lesson. Thank you. Thank you again. Oh, and here is Henry. She is not with us. So we are used to doing biology at this level. Ecologists who like to do terrestrial ecology. What part of here is looking up to the canopies, and we decided to try sending 5 or 6 containers up there, and there were bees. So we have to expand our horizon. Next one. Okay, on the to-do list, statistical analysis of the data. I will try to provide an example, and maybe time will be enough for me to talk a little bit. Process the bees for pollen. This is yet another swanky image produced by Dr. User. This is Solidago, and I understand that they tend to flower later on, like in September. So, and this came from a bee collected by the Purpose. So we plan to collaborate with Dr. Euchre, whereby Penn State undergraduates working with me. Maybe Kelsey will help me, please. And get a bunch of slides ready, have the undergraduates take a look at pollen at Penn State. You can realize that different families of pollen have different shapes, etc. And then ship everything to Dr. Euchre so that Western Carolina University, using his expensive toys, can produce these images. Okay. Next slide. I have now like plenty to get started. Okay, what I have learned. So we have so far 58 species of bees at the Highlands Biological Station. I hope that by October we'll have all of the bees identified, and by December I hope that all of the statistical analysis are completed. Only preliminarily, because remember, I've only been here from May to July. There are things happening the rest of the year. Not a lot during the winter, but anyway. Okay, so if everything pans out, I hope to return in September, maybe return in the future summer. Why am I interested in all of it? Because people, the broad public, who are all of us, US taxpayer dollars, like us to pay attention to pollination biology, conservation issues, and many of us are gardeners. So we have vested interest in all of this. Punchline, no bees, no food. Next one. Okay, we have enough time to say a few things and leave enough time for questions. One of the lessons I have learned as a scientist is humbleness. And as Albert Einstein said, next one. So at night, a long day of work, that's where my former office used to be. Time to go to bed. Next morning with the lights on, ready to go. But when I get tired of bees or it is raining like today, I haven't seen a single bee today. No, that's incorrect. They were hiding like a chicken under the flowers. I took beautiful photos because they were steady. Thank you. Next one. So I was working in some other things. I did a big boom, 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 boom. Okay. Scorpion number from the country that used to be called Burma, about 100 million years old, that finally out for review, dragging this for about 6 or 7 years. I am trying to finish, and we have maps of the first arthropod in amber from Texas. Most people don't know that there is amber in Texas. I don't know it either. And these are the localities so far in red plus this great locality, amber, Texas Gulf Coast, okay? Somewhere around here. So I didn't put a dot there. And this is how North America used to look about 95 million years ago when this is the age of the fossil, a little bit younger than the scorpion. There. So most of a good chunk of real estate of the US was underwater. Next slide. Okay, this is the technique I plan to use for the analysis of the bees. It's non-metric multidimensional scaling. I didn't have time to plug R in and let you see how it is generated and the cube rotating and all of that. I love it. So this is completely different. This is my real responsibility at the National Museum of Natural History. I am supposed to be helping my supervisor, Dr. Conrad Lavandera, on the analysis of fossil insects, fossil plants, insect-plant interactions in the fossil record. And here, from northwestern United States and southwestern Canada, what we now know of those countries, we have a few examples in our holdings, only one in the photograph. This of a leaf with these type of markings. We strongly believe that those markings, I don't know him, so are made by damselflies laying eggs on leaves and leaving these oval marks that are preserved millions of years. So all of these little black dots are the damage type 54, DT54, but there are many others. There are over 300 categorized damage types produced by insects, owing to the fact that there is an enormous variety of insect mouthparts, not just the 4 or 5 that are taught to us in basic entomology. One looks in great detail, it's tremendous variety. And also has something to do with the type of plants and what are they doing with chewing on the plant to eat or laying eggs or whatever. So we consider the species of fossil plant, and we let the paleobotanist tell us the name is really top in my opinion. Some sort of characteristic of the leaf that can be observed by someone with experience, and the damage type, which my supervisor and I do, listening over radio. And we tell the machine, okay, put all of that together, and that's what we get. Now, to get this, we have a code designed by Peter Lawson, who perhaps is in attendance. So thank you, Peter. That is able to generate that with about 500 lines of code, not for the faint of heart. Next slide, definitely not. So my hope is that I will do that. You can go to the previous slide. Thank you, maybe. So obviously we can see that the red circles or red spheres are all over, but the blue ones on top, so there is some separation there and is statistically supported. We'll see when we finish that. So I plan to do the same with the different areas of the Highlands Biological Station based on what species are present and how often. Next one, please. Okay, this is another project that is one of those things that one does to help someone else, and one gets totally irreconcilable, it cannot be detached, evolved. And so this is research by some of my colleagues in Puerto Rico, and they asked me for help. I said, okay, sure, I'm happy to help. And 9 months later, we are still dealing with this using yet another software, not R, but Stata. And we are on our way. So to finish this particular project. So this is in a lagoon in northeastern Puerto Rico. The airport will be about maybe there at this particular scale, excuse me. This is the lagoon, okay, Laguna Grande, and they noticed that when the sargassum came in through a canal not shown here, the composition of algae was completely changed, and the bioluminescence. This is one of the bioluminescent bays in Puerto Rico, which are several, an important touristic place, by the way. And after not only looking at the data but analyzing it, very, very clear to us that this still needs to be panned out statistically. That's later this week after I return home, that there were some species of algae that increased when the sargassum came, some others that said goodbye, that okay, decreased or rarely seen, and then some others that did not care. So we want to put some numbers into this. Next slide, next project.
What is sargassum?
Oh, sargassum is a big brown floating algae. Yes, thank you for asking that question. Okay, now into the last 3 slides. For the last roughly 10 years, and I have been, well, for many years I've been interested in history, especially history of science. I have a lot to say about that, and I know Jim as well with your recent book about what. Some other day, we can talk more. Okay, so punchline of this project, genetics before Mendel, is that Mendel gets the A, so to speak. But Mendel entitled his mid-18th century paper, Experiments on Hybridization of Peas, for a reason that is rarely, if ever, mentioned in the classroom. Mendel worked with bees, okay, those very, very common, and with other species of plants, and he did not, I repeat, did not get the 3-to-1 ratio, only with peas. And fair and square, he reported, these are the ratios I get on peas, okay? But we are not taught that part in school. I've never heard it, okay? So that's part 1. Part 2, it was an advantage for Mendel. His birthday, his 200th birthday was last week. I'm fully expecting a question about Mendel later on if you wish to ask it. But there were some other, it was an advantage to be a member of the, of the clergy, because the government was very authoritarian and didn't like people messing up with these type of things, which was not called, by the way, genetics. Just like governments don't like people today to think or less, even talk about cloning humans. Right? All of these ethical issues. So put yourself 200 years ago, they didn't like people doing that. War was a very important factor because the Austro-Hungarian Empire, in which Mendel resided, was at war with the Napoleonic Empire, okay, with France. Soldiers in Europe need warm clothing in the middle of the winter. They're going to be out there killing each other, okay? So the sheep, the so-called sheep breeders, such as in-breed aesthetics, were doing experiments, trying to get sheep to produce the kind of wool that would be suitable to dress a soldier. Most of them were for the money, of course, but some of them were for the money and to try to understand what's going on. If you read papers like in-breed aesthetics shown here, you will see a statement such as the characteristics of the parents sometimes are not seen on the progeny, on the F1. but seen on the grandchildren, the F2. Ooh, that sounds like Mendel, good 40 years before Mendel, right? But they were using sheep, not peas, okay? So from beginning to end, this paper on another guy by the last name of Ehrenfels began and ended while I was at the station. So the story behind that is that we have promised the editor of the journal Genes to send them something for their issue on sheep breeding. And then my colleague said, oh, I don't have time for that. I want to politely decline. And I replied saying, that's not very good. Why don't we try? And his reply was, Jorge, why don't you write a draft? So on a Saturday night, before going to the research triangle and to see my wife, I produced the original draft. And this guy knows so much about genetics for Mendel that next day there was a nice manuscript waiting for me at the hotel. So that was, next one. Okay, the last two will be a little bit rough. So, how many of you know of Leopold and Love, Crime of the Century? This guy is Nathan Leopold. At age 15 in Chicago, he was the third author on a paper on a new record of birth. The first author was James B. Watson, the father of B. Watson of Watson and Crick. Okay, so this guy was published. He and his boyfriend, Richard Love, the youngest guy ever admitted to the University of Michigan, age 17, and I checked with the registrar. He still holds the record. Decided to commit the crime of the century, and they murdered. Oh, so he was a scientist before deciding to do something, in my opinion, really crazy. Okay, and they decided to murder little poor because of the sad ending, very rich, Bobby Frank, age 14, a minor. Why? Quote, for the thrill of it. How? Quote, so it's like squashing a ball, and for an homologist that has a certain meaning. They got life, was 99. He was let go after only, in my opinion, only 33 years. And of all places on this earth that he could have gone, he went to a place closest to my heart, to the very place where my mom was born, to the mountains of central western Puerto Rico, where he made the rest of his life. We are chasing all of the records, and I have my friends from high school went into different professions, and one of them used to be one of the chief prosecutors in Puerto Rico. And when I explained this to him, for him, don't worry, I can get all of that to you. So we are waiting. Anyways, next slide. Okay. I am a faculty member, as all of you know. I don't like academic dishonesty. And this is what my colleague Fred Englander and I hypothesize that academia in this country and many other countries, including Puerto Rico, is a machinery that involves many, many, many tools. He has been reading, I have been arranging interviews beginning last summer from the Highlands, okay, from the colleges we were conducting interviews. Punchline. So this is I'm sure underestimated rate of academic dishonesty. We believe, for many reasons we don't have time to explain, this is not sustainable to do. Not everyone is meant to go to college. I really think it's true. The Germans have done this for eons. If we choose to go to university, do meaningful hands-on education, just as the Highlands Biological Station wants to do. And then the third point is the little things we can do here in our own classroom. So we're working on that. Next. Okay. In summary, I have tried to do a lot of research, learning with Peter and Ed. taking care of my journal, writing about bees in newspapers, involving the Redbud project, of which I said 0 words. And then while here, meeting Laura, Miss Laura Bogues, with whom I'm collaborating in the transplantation experiments that we will resume again. And with John, I'm so sad he's not here. So this happened, I think the week after those two ladies said, we don't remember you, but we remember you. Comes at the same place at the bog, I collected this. I said, what the heck are those things? And so I eventually showed them to John, and he said, John, he said to me, Jorge, I have never seen Coremata, which is the name of those irreversible structures, ever in my life. So if John hasn't seen them, and he tells me this has rarely been imaged, let alone imaged with electron microscopy, I asked John, we have a paper, right? Next slide. Okay, this is my punchline. Meaning of life is to find our gifts, and the purpose is just to give it away and be happy. Next slide. And I'll remember all of you, including the ladies, the ones who said we don't remember you. Hannah, this is for you here, your bananas. Thank you for everything. My former office, photograph, thank you very much. Winter, next slide. What waits for me? My dearie, hopefully still on the Zoom. Our garden, this part was added by her over the weekend. Sam, and he's in his lab. I will never be as good as he is, but I am getting up there. And all of the crazy stuff that makes me laugh, like this one. Both Sasquatch is big, he's real, unlike those other guys. I just love doing this. This is how I want to remember my stay here with tremendous peace, which is the big thing that has happened for me. Thank you very much. Floor and question from Zoom. Yes, questions. I wonder if there are questions on the chat.
Yeah. Those right here.
Who are the main predators of bees? Main predators of bees are wasps. I'm sure if a bee is not careful enough, a spider can get it. Bees also have lots of parasites and diseases. How long a typical bee, like a typical andrinid, is active for 2-3 weeks, and then takes lays the eggs and provision them with pollen. And for most of us, our image of bees is the honeybee, and the honeybee is way up there, way up there. Most bees are not like the honeybee. Most bees tend to be solitary and have nests on little holes in the branches of trees or in the dirt, up to about, let's see, how 1 to 3 feet deep and several feet long, like in the case of honeybee. Question from the floor. This is the floor here.
Yeah, I don't want to get away from bees, but I live in the Caribbean and we have a big problem with sargassum. So is there a theory why the algae ecology is changing?
In that particular lagoon, the speculation is that the chemistry associated with the sargassum affected the
chemistry?
The chemistry of the sargassum, the stuff that the sargassum oozes. Yeah, so I don't think my colleagues know specifically what happened. They only documented, or they want to document exactly what happened. And the bioluminescence, as I tried to say, changed dramatically. More questions.
Our vegetables you have access to his collection of bees?
To Mitchell's,
Yeah,
I haven't yet asked, but eventually I may have to. North Carolina State University.
well, just wondering, would you be re-identifying those?
I will just take a look. I think saying re-identifying it makes me nervous because he's the father of Eastern North America. Bees, but heaven knows, all of us make mistakes.
So unlike plant taxonomy, the bee taxonomy really hasn't changed in 100 years.
I think, no, I would not agree with that. I think there are lots of species that have been described recently. So what may have happened to Mitchell is that he was identifying bees according to his concept of species. But especially in the last 20 plus years, there have been lots of new species, especially of lights of blossoms. The tiny ones. the tiny ones that nobody wants to deal with. Any more questions?
A little unrelated, but
Go for it.
A yellow jacket, is that in a wasp family?
Yes,
Okay.
it's ones. Yeah. And they are more impatient than impatient.
Thank you, I know that.
Yeah. Right.
Do you like all the species that we have here, they all have tongues?
Yes, all of them. So one of the projects that's kind of floating in my head is just concentrating on bumpus and the pollination garden and asking the question, what type of flowers they like to visit, what flower colors they like the best. Any more questions? Yeah.
I'm curious about the absence of so many of those leafcutter bee species that were reported.
Yes, maybe.
And, you know, thinking about their biology, it's not so much the flowers, the pollen, but more possibly the type of vegetation they use that they're cutting
Mm-hmm.
and the type of vegetation that they're inserting building their nests in.
Yeah.
But my feeling is that very little is known about their nesting behavior.
That is correct. And a few months ago, after noticing that happen, I read a paper about the sensitivity of megachilids to insecticide and that registered. So, but I don't know for sure what has happened. Have you?
So you found only one of about a dozen
Yeah.
species that Mitchell found.
So far. Maybe we may have found one or two more in the unidentified material. Yeah. Really dramatic, drastic, very drastic change.
Yeah.
Sure, there is always a possibility. I'm sure Highlands for Mitchell was more than this area, but we cannot be so different from the rest of us. Any more questions? Thank you for all of you. Thank you for your kindness. Thank you for everything. And thank you.